for this section, we have a formula. The probability of B if A has already happened. So let's talk about this part first before I discuss what it is. Remember our symbol such that. So what this really reads is the probability of event B happening such that A has already occurred. So I'm going to give you some information. I'm going to tell you one event's happened. What's the chance that the second event occurred in that case? Well, what's it going to be? It's still going to be desired outcomes divided by total possible. What are the desired outcomes? It's the probability of both B and A occurring. Because I'm telling you, A's already gone down, so you have to use that information. B intersect A, then it's going to be that probability. And my total possible, I'm not dividing by everything in the world. Instead, I'm dividing by the chance that A happened. Because again, A's already occurred. So that's our formula, our new formula for this section. We're going to use it sometimes if we need to. Using microexpressions, psychological profiling, and searing radiation, the TSA need only use enhanced investigative techniques on 2% of travelers. Of these, 70% require further full interrogation by other federal agencies. So now what's the chance that a random traveler is going to end up getting fully interrogated? On the one hand, you're rather unlikely to get picked up for further stuff, but once you're picked up, they're pretty good at picking up the right people. Okay, so let's look at this. This one's best actually understood by a tree diagram. Here I am. I actually fly quite a bit for DC. I'm walking through. Here's my little security gate. About to walk through my security gate. One of two things can happen to me. Either I can join the 2% of people who gets further checked, or I get to go right through that gate and join the 98% of people who absolutely nothing happens to. Next, if I get checked further, well, I've got a 70% chance of pretty much getting completely red flagged and needing to be fully investigated by lots of other agencies. Still, though, there's that little bit, that 30% chance that I just accidentally set off some stuff, and again, I get to go on and fly on my little plane. Here's my little airplane. Over here's my little airplane. These ways, life is pretty good. This one, not so much. So what's my chance? Well, if I draw it out in a tree diagram, it's pretty straightforward. It's this times this. So I'm just going to have 7 times 2 is 14. And I've got 1, 2, 3 decimals. 1, 2, 3 decimals. So my chance of actually going down this path, this part's pretty small. Once I've gone down here, it is more likely that I'm going to miss my plane because of interrogation, but still, overall, it's a little bit over a 1% chance that I'll actually be fully interrogated. Sounds kind of scary. So some of these problems for a conditional probability, and it's conditional because before I could be fully interrogated, I had to be selected for more information in the first place, so something had to have set them off. You've got this conditions imposed on it, so you can just go through and multiply. This right here would have been called maybe the probability of enhanced investigation. This would be the probability of the complement of enhanced investigation. This right here, this 70% going on, is going to be the probability of further interrogation, provided that this interrogation up here has already occurred. So we got these things. Notice that at every step of my tree diagram, it has to add up to 100%. Let's look at another example. The probability that a male in some country lives to age 60 is 83%, 60 or over. The probability that he will live to at least 80 years of age is only 37%. But what's the chance that a 60-year-old male lives to age 80? The way to think about this isn't entirely right, but it's on the right track. Think of it. I'm under 60 now. I've got a lot of opportunities to do myself in prior to age 60. I could get in a wreck, I could be going on airplanes, I could decide to take up dirt biking, or I don't know, I could start playing knives with gangsters. I have no idea how you play knives with gangsters, but I could. So the probability that I live to age 60 is pretty high, but still I've got this chance of not doing it. However, once I get to 60, I've sort of lost all those chances that would have also, of course, stopped me from reaching age 80. So when you're looking at this sort of thing, this is exactly the type of thing that's maybe not quite as much a tree diagram as it is using this formula. Only instead of B and A, my event B is 80, and my event A is 60. So what's the probability of living to 80 if I know I've already lived to 60? Well, based on my formula, I need to find the chances of 80 intersecting 60. I need to know that probability, and I'm going to divide it by the chance of me living to 60. Well, 80 or more is 37% chance. That's part of 60 or more. 60 or more starts here. 80 or more starts here. So this whole thing here was 83%. This little piece right here was 37%. But this is definitely the common ground. That's the intersection. So I have 0.37 on top here. The probability of living to 60 was 83%. Over here were the people who lived less than 60. And that was going to be what, 7 and 17%. 17% of people don't make it to age 60. When I do this division, notice I get some increase going on. If I do 0.37 divided by 0.83, I get myself 45% with rounding. Once you've made it to age 60, you're almost got a 50% chance of living to 80. Which means if you go back to that problem from the financial section about retirement, you need to recalibrate your retirement a little. The longer you live, the more likely you are to live longer. You've sort of already managed to avoid chances of dying. You've succeeded, you've won. So when you're planning your retirement, you're not just planning on living to 65, let's say, which is somewhere in here. You're also planning on the fact that once you live to be 60, you're more likely to live even further. So you can't just go and plan your retirement based on what's the chance of me living, the average American expectancy is X number of years. That's not what you're planning your retirement on. You're going to retire at age 65, let's say. That's probably going to change by the time we retire, but anyway, it's there. When you're looking at that age 65, you have to think, if you are age 65, how many more years does somebody who's age 65 expect to live? That percent increases. So you might need to be planning for a longer period of retirement than you're initially thinking right now. It's not just based on average life expectancies, it's based on this. But all these things that we're doing are basing themselves on this idea that if I know something's happened, it changes my total possible outcomes, which ends up changing my likelihood of a particular event happening. It went from 37 all the way up to 45.